Here's how the avian respiratory system pulls off its little trick of unidirectional airflow. As we learned in class, you have posterior sacs that pull air in and then subsequently push them into the lungs. You have anterior sacs that pull the used air, depleted oxygen air out of the lung and then push it on out. This is just a brief animation of that. Um, at first, you're going to see an animation that just shows it follows one set of air. So the bird inhales, goes into the posterior sac. The bird exhales, pushes that air into the lungs, where oxygen and CO2 get exchanged. The depleted air on the next breath, bird inhales, it sucks that into the anterior, and when it exhales, it goes on out. Now, that is why, I'm going to pause it, that is why they say that there are two breaths that are required to pass any given set of air through. Those are identical operations. All the bird does is inhale and exhale. And the exact same thing is happening with every inhale and exhale. It's just that to get one volume of air all the way through the system, it requires two breaths. But there's nothing special about any given breath, inhale or exhale. And that's shown here, where they're going to show this continuous uh, motion. So every inhalation does this. It simultaneously pulls air in here and pulls it out here. This is happening with every breath. Same identical thing. Nothing special. Okay. Now, one thing that you should realize is that these individual, and this is, of course, a simplified system. It's showing one posterior, one anterior. As we learned, there are 9 altogether. There are 4 posteriors and I think 5 anteriors. Um, One thing to realize, to keep in mind is these are not independently, they don't have independent muscles coordinating with each other, opening individual sacs and closing sacs. This is a very passive system. All of these air sacs are in this cavity of the bird. All the bird does is expand their thorax, and everything does its job. All of the sacs expand. When it exhales, they all contract in sync. All right, so it's just one motion. Bird inhales, every sac inflates. They exhale, every sac deflates. Okay, so then you might wonder, well, how do they pull this unidirectional thing off? Well, your first instinct would be valves that just force it to go in this direction. Well, it turns out birds have no respiratory valves. None, not one of these. None of these junctions have valves. They're all just open. It's just one big system. Now, if I set up a bellows system, or I got some kind of a large Leyden jar and cut out the bottom and put a rubber sack, a balloon or something across the bottom, and then the trachea would be the opening of that jar. And I had a series of tubes and balloons. This wouldn't happen. You're not going to get unidirectional flow that way. They're just all going to, the air's just going to equally go into everything and then come out. So how do the birds pull this off? Well, this is how. Uh, they've done studies and simulations, and here's a simple simulation to get the basic principle across. If you look at illustration C, you have, this is just a pipe set up with this upper loop and a piston down here. And the piston goes back and forth rapidly. And when they have sufficient amplitude and frequency of back and forth motion, it turns out that it does flow in one direction only. It always goes in this direction. Here's why. There are no valves in this. If you look at the blue direction first, so at the bottom, the piston moves to the right. You get up to this upper level, the water's moving to the left down here. It has two directions it can go in. It prefers this direction, and if you want, you pause the video and ask yourself, why does it prefer to go straight instead of go up? Okay, well, just simply Newton's first law, inertia. Things in motion tend to stay in motion in the same direction at the same speed unless a force acts on them. This has got inertia going forward. It has a bias in the forward direction. Sure, some of it could come up here, but that requires some kind of additional force to get it to go in that direction. When it gets here, the same water hits this junction, and this time it can go left or right. Those are symmetrical. So there's no bias either direction. So if you've got this loop up here where on this side there's a bias for the liquid to go straight through here, and here there's no bias whatsoever, it's going to favor that direction so that water will tend to want to go in this direction. In the red direction, when the piston goes the other way, the same thing happens here. Coming off to the left side here, the water going up wants to keep going up. It doesn't want to turn right suddenly. So when it goes in the opposite direction, and now it wants to push upward, it keeps going up, which again has the bias going this way. And then, of course, the water coming here can go left or right. It's symmetrical, no bias there. All right, that's one factor. Another factor is shown in this illustration over here at D. The first one in the foreground, this schematic, shows the direction, the blue direction. When the water comes speeding to the left here, it creates the Bernoulli effect. Says that it's going to create a little low pressure here, and it's going to pull the water down. This is just like an aspirator tube in a chemistry lab. So it pulls it down, and what happens when it comes down? It gets hit with this stream of water, and it tends to rotate. So this sets up a vortex right here, and they verified this. This is not just theoretical. So it creates a vortex. Well, now that there's a vortex, when this water comes along here, the vortex serves as a sort of a plug, because now the water, if it wanted to go up here, it's going to get hit with this clockwise flow. It's going to push it down, and its momentum is just going to keep it going. So this vortex does act like a plug. When it goes in the opposite direction, when it comes back this way, now, once again, there's water spinning, but now it kind of opens up the door for the water to come out this spinning side from down here. So water kind of equally comes from the top and from the left to go on its merry way to the right. That plug kind of now is hugging the left side of the wall here, and the water can just flow right out. So that vortex serves a purpose in both directions to keep this moving in this unidirectional fashion. So there are other factors, for example, something called the compliance of each individual air sac. Compliance is a combination of its capacity, how much air it will hold, and its the elasticity of the air sac, how much it resists being inflated when the bird inhales. Those combinations also are a factor in determining how the air flows through the system. So the coolest thing, I just think if it wasn't, if birds weren't fascinating enough, just the idea that they've come up with a system that not only ensures that the air goes in one direction, uh, but also pulls it off without a single valve. Uh, that nothing, if nothing's closing and opening, it's just that much more efficient. Stuff's going to move through faster, and you're not going to have something that can fail. You're not going to get a prolapse or something. It's just, it's a brilliant system. It's just, I'm really in awe